Question number 1. Find the maximum value of the given determinant. First row is 1, 1, 1. Then second row 1, 1 plus sine theta 1. Then 1, 1, 1 plus cos theta. We have to find the maximum value of this determinant. For this, if I make two zeros, it will be better for me to expand. So for this, I am going to do column 2 gives column 2 minus column 1 and column 3 gives column 3 minus column 1. So first column we are writing as it is. Second column 2 minus column 1. So this becomes 0, then sine theta, then 0. Then column 3 minus column 1, 0, 0 and cos theta. So when I expand this, I will be getting only sine theta into cos theta, and this is nothing but sine 2 theta by 2. Okay, now we want the maximum value. The maximum value of sine theta or sine of anything is 1. So even if I put that value as 1 here, the maximum value of this given determinant is 1 by 2. Question number 2. If A is a square matrix such that A square equal to I, then find the simplified value of A minus I whole cube plus A plus I whole cube minus 7A. Now let us expand A minus I whole cube and A plus I whole cube. Then we will include minus 7A also. So this is A cube minus B cube minus 3A square B plus 3AB square. So this formula I applied. Wherever B is there, I put I. In the same way, plus the second term is A cube plus B cube. So I have to write I cube plus 3A square I plus 3AI square, then minus 7A. So I wrote one below the other so that minus I cube plus I cube I can cancel, and these two also I can cancel. So now this is 2A cube plus 6AI square minus 7A. Anyway, in the question it is given A square is I. So this I am purposely splitting into A square into A plus 6A. I square is anyway 1, so I am not writing it. So I get like this. Now if I replace this as I and 2I is 2, so 2A plus 6A minus 7A, totally 8A minus A, it is going to become A. Matrix A is given and they have given it is a symmetric. Now find the values of A and B. When it is a symmetric matrix, after the transpose, the elements should be same. Suppose if you have A here, B here, C here, then definitely these also should be B and C. Suppose if some other element E here, then D here, then this should be D and F. So this is one general matrix where even after the transpose you will find the same matrix again. So for that, this element is A, that is the element A, first row second column, and this element is second row first column. So these two should be same. Similarly, A31 and A13 should be same. That's why it is symmetric. Now in the given matrix 0, 2b minus 2, 3, 1, 3, 3a, 3 minus 1. Since it is symmetric, we know these two should be same. So 2b equal to 3, that will give b is equal to 3 by 2. Similarly, these two should be same. So 3a equal to minus 2. So a is equal to minus 2 by 3. So the values of a and b are a is minus 2 by 3 and b is 3 by 2. Question number 4. Find the position vector of a point which divides the join of points with the position vector a vector minus 2b and 2a vector plus b externally in the ratio 2 is to 1. So I'll take a vector in the diagram. This is OA vector and they have given this is a minus 2b, and OB vector I will take, which is 2a plus b. It is dividing in the ratio 2 is to 1. Since it is given externally, I am going to use the externally point. So the formula is, suppose this is the point C. So according to the formula, suppose if this is the ratio m is to n, so m OB vector minus n OA vector whole divided by m minus n. Since it is externally, I have to put minus sign. In the diagram I am marking it, but in the formula it is a minus sign. So m is what? 2. 2 into 2a plus b minus 1 into a minus 2b whole divided by m minus n, which is 2 minus 1. So this is 4a vector plus 2b minus a plus 2b whole divided by 1. So answer is 3a vector plus 4b vector. Question number 5. The two vectors j plus k and 3i minus j plus 4k represent two sides AB and AC respectively of the triangle ABC. Find the length of the median through A. We'll draw the triangle. Name the triangle as A, B and C. AB is j plus k and AC is 3i minus j plus 4k. Find the length of the median through A. So median, it will connect the midpoint of the opposite. So I will take this as D. It is in the ratio 1 is to 1. It is similar to the previous problem. Just use the section formula. Take this as ratio m is to n. So in this diagram, it is supposed to be m AC vector plus n AB vector whole divided by m plus n. Since m and n are 1, so it is basically adding AC with AB, that is 3i minus j plus 4k plus j plus k whole divided by 2, because m plus n is 2. So this is going to be 3i minus j plus j we can cancel plus 5k whole divided by 2. Since we want the magnitude, that is the length. Since we want the length, we have to find the magnitude. So this is nothing but 1 by 2 root of 9 plus 25. So it is half root 34. This is the length of the median through A. Question number 6. Find the vector equation of the plane which is at a distance of 5 units from the origin and its normal vector is 2i minus 3j plus 6k. They have given normal vector, that is n vector is equal to 2i minus 3j plus 6k, and equation of the plane is r dot n cap is equal to d, where d is the perpendicular distance from the origin. So r dot, for writing n cap, I have to write the n vector and I have to divide by the magnitude. Then only I will get n cap, because n cap is a unit vector. So root of 4 plus 9 plus 36, and the perpendicular distance from the origin is given as 5. So totally r vector dot 2i minus 3j plus 6k whole divided by 7 is equal to 5, because the denominator is root 49, which is 7. So if you want, you can leave the answer like this, or if you want, you can carry the 7 to the other side. That will give 2i minus 3j plus 6k equal to 35. This is the required equation of the plane, vector equation of the plane. Coming to section B, question number 7. Prove that tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 plus tan inverse 1 by 8 is equal to pi by 4. So I will apply the formula for the first two term, that is tan inverse x plus y by 1 minus xy. I apply the formula. Similarly, for the next two term, if I apply the formula, 1 by 3 plus 1 by 8 whole divided by 1 minus 1 by 3 into 1 by 8. So I took the LHS part and applied the formula. Now the first term is going to become, after taking LCM, numerator is 12 by 35 whole divided by, this is 35 minus 1 whole divided by 35. So 35 we can cancel. In the same way, if I simplify this, it is going to be 11 by 24 whole divided by, after taking LCM, the denominator will become 24 minus 1, so 23 by 24. So we can cancel these two. So we left with 12 by 34 here. This whole thing is 34. So if I cancel with the two table, so this is going to be 6 and 17. So finally we left with 6 by 17 plus here 11 by 23 whole divided by 1 minus 6 by 17 into 11 by 23. So now we have to take LCM. The LCM is 17 into 23. So this is going to be in the numerator 6 into 23. So 23 into 6. So 18, 12, 13, 138. And 17 into 11 is 17 into 11 is 280, sorry, 187. So if I add 187 with this, I'll write it again, 138 with 187. So 5 times. So totally I'm getting 325 in the numerator. Okay. Then whole divided by this we have to multiply. So 23 into 17, that is going to be 7 3 21, 14 15 16, then 23, then this is going to be 391 minus 66 I have to do, because after taking LCM this will get subtracted. So this is 5, then 2, then 2. So 225, sorry, 325. So 325 by the LCM is 17 into 23. So we can cancel the denominators and numerator also. So basically we left with tan inverse 1, which is nothing but pi by 4. Question number 7, or part, where we have to solve. So it means we have to get the value of x. So in the LHS we have tan inverse cos x. So I will write this as tan inverse cos x plus tan inverse cos x, because we have two tan inverse cos x. And the other side I am writing as it is, which is tan inverse 2 cosecant x. In LHS I am going to apply tan inverse x plus tan inverse y formula. So tan inverse x plus y, so cos x plus cos x whole divided by 1 minus xy, so 1 minus cos square x, equal to tan inverse 2 by sin x I can write, because cosecant x 1 by sin. So tan inverse we can cancel on both the sides. So this side 2 cos x by sin square x equal to 2 by sin x. So 2 we can cancel, sin and sin square also we can cancel. Finally cot x is equal to 1, which implies x is equal to pi by 4. Question number 8. The monthly incomes of Aryan and Baban are in the ratio 3:4. So we will take the income ratio, which is given as 3:4. So the actual income is going to be 3x and 4x. In the same way, their monthly expenditure are in the ratio 5:7. So I will write directly the actual expenditure. It is going to be 5y and 7y. I have to take a different ratio because one is income, other is expenditure. Now each saves 15,000 per month. It means the income minus expenditure is the saving which is 15,000 for the first person. Similarly, for the second person, the income is 4x and the expenditure is 7y. This also 15,000. Now find their monthly income using the matrix method. So this we have to write as a matrix product. These two are the equation which I have to take only the coefficients and write as a matrix product in this way, and after that using the matrix method we are going to solve this to find the income, find their monthly income. So now this is of the form Ax equal to B. It means x is equal to A inverse into B. So if I find A inverse, I can multiply with the B. For finding A inverse, we have a shortcut method, that is first to find the determinant A, that is nothing but, I'll do it here, determinant A is nothing but minus 21 plus 20. So it is minus 1, which is not equal to 0. Therefore, A inverse exists. Now, A inverse is nothing but 1 by A determinant into adjoint A. 1 by A determinant is 1 by minus 1. For writing the adjoint A, these two elements we have to interchange. That is minus 7 and 3 here. And these two elements we have to change the sign. So minus 5 will put 5 and plus 4 I will put minus 4. Now I got the A inverse. Now the value of x is nothing but A inverse into B. Since we have a minus sign here, I will take it inside. So 7 minus 5, 4 and 3 is our A inverse, and B is nothing but 15,000 and 15,000. The question is asking only their income. So if I find x, that is sufficient. For finding the x, I have to multiply this with this. That is a matrix multiplication. So I'll do the matrix multiplication here. That is 7 into 15,000 here. Then minus 5 into 15,000. Then 4 into 15,000 plus 3 into 15,000. Okay. So the first row I can do it in a short. 7 minus 5, 2. So 2 into 15,000, totally it is 30,000. And this is 4 into 3. Sorry, 4 plus 3, so 7. So 15 into 7, 105 with 3 zeros. Okay. And I got the monthly. Just a minute, when I change the sign here, this is supposed to be minus 3. So even here it is minus. So totally it is only 15,000. So the value of x is 30,000 and the value of y is 15,000. Here the question is asking for their income. So income already we assumed as the actual income is 3x and 4x. So if I multiply the value of x here, the first person, that is Aryan income, is going to be 90,000, and the next person Baban income is going to be 4 times, so 1,20,000. And this problem reflects which value is the another question. So whatever value based you can write, like saving is a good habit, etc. Whatever you feel you can write. Question number 9. If x is equal to a sin t into 1 plus cos 2t and y is equal to b cos 2t into 1 minus cos 2t, find the value of dy by dx at t is equal to pi by 4 and t is equal to pi by 3. So the value of x is given as a sine 2t into 1 plus cos 2t. For finding dx by dt, I have to follow UV method. For this, a is a constant, we'll keep it out. So sine 2t into differentiation of this is minus sine 2t into 2 plus 1 plus cos 2t into cos 2t into 2. Now the entire term has 2 common, so we will take it outside. After taking it outside, we get minus sine square 2t plus cos 2t plus cos square 2t. Now cos square 2t minus sine square 2t, if we combine, it is going to be cos 4t, because cos 2t is cos square t minus sine square t. So if I apply the formula, this will become cos 4t plus cos 2t. Okay. So this we will keep it as it is. Now coming to y. Y is given as b cos 2t into 1 minus cos 2t. Now we have to find dy by dt. B is constant. So by following UV method, cos 2t into, this is going to be sin 2t into 2 plus 1 minus cos 2t into minus sin 2t into 2. So once again 2 is common throughout. So 2 if I take out, this is going to be cos 2t into sin 2t. But if 2 is inside, I can change the entire term itself sin 4t. So better we will not take 2 common here. Okay. Then this if I multiply inside, minus 2 sin 2t, then plus 2 sin 2t into cos 2t. Once again this is going to be sin 4t, and already there is a sin 4t. Totally it is going to be 2 sin 4t. So 2 sin 4t minus 2 sin 2t. Now I could have taken the 2 common. So 2b into sin 4t minus sin 2t. So we got the value of dx by dt and dy by dt. Now we have to find dy by dx. For that we will divide. So dy by dx is nothing but dy by dt whole divided by dx by dt. We can cancel 2 and 2. We are going to apply the formula. This formula is 2 cos c plus d by 2. So totally 3t into sin c minus d by 2. That is sin t alone I will get. Whole divided by a into, this is 2 cos 3t into cos t. So in the numerator, sin c minus sin d is 2 cos c plus d by 2 into sin c minus d by 2. In the cos, in the denominator we have cos c plus cos d form, so both are cos. So we can cancel 2 cos 3t and 2 cos 3t. Finally, we left with dy by dt as, dy by dx as b by a tan t. Now in the question they are asking two part. One is when t is equal to pi by 4. So when t is equal to pi by 4, then dy by dx will become b by a, because tan pi by 4 is 1. Then at t is equal to pi by 3, when t is equal to pi by 3, then dy by dx is b by a into root 3 because tan pi by 3 is root 3. Coming to the next OR question, they have given y is equal to x power x and we have to prove the given expression, that is d square y by dx square minus 1 by y into dy by dx whole square minus y by x. Since y equal to x power x, we have to take log on both the sides. So log y equal to log of x power x. Then this is log y equal to x log x. We'll differentiate on both the sides. 1 by y into dy by dx equal to x into 1 by x plus log x into 1. So basically this is 1 by y into dy by dx equal to 1 plus log x. Now we will carry this y to the other side. So dy by dx is equal to y into 1 plus log x. Now we'll find the second order, that is d square y by dx square equal to, we have to follow UV method. So y into 1 by x plus 1 plus log x into dy by dx. But in the given proof there is no log term. So what is 1 plus log x from here? I should replace it here. I'll take this as 1. Then from 1, what happens is our expression is going to be d square y by dx square is equal to y by x plus 1 by y dy by dx, and already there is one dy by dx, so to become dy by dx whole square. So if I bring both the term to the other side, I get the answer. So d square y by dx square minus 1 by y into dy by dx whole square minus y by x equal to 0. Question number 10. Find the values of p and q for which the given function is continuous at x is equal to pi by 2. So when I take the first part, f of x limit x tending to pi by 2 minus. For this I have to choose 1 minus sine cube x whole divided by 3 cos square x, where limit extending to pi by 2. If I substitute pi by 2 for x, I will be getting 0 by 0 in both numerator and denominator, which is indeterminate form. So I have to rearrange the numerator. I am going to apply a cube minus b cube formula, which is a minus b into a plus ab plus b square whole divided by denominator is cos square x, which can be written as 1 minus sine square x, which can be further factorized into 1 minus sine x into 1 plus sine x. So I can cancel 1 minus sine x. After that, if I substitute the limit extending to pi by 2, the value of the numerator will become 3 and the denominator is 3 into 2 because sine pi by 2 is 1. So the value is 1 by 2. Then coming to the second part, where limit extending to pi by 2 f of x, for this I have to choose a function p. So the answer itself p. So we got half for the first part and p for the second one. Coming to the third part, f of x limit x tending to pi by 2 plus. For this I have to choose the last one, which is q into 1 minus sine x whole divided by pi minus 2x whole square. If I substitute pi by 2, again I will be getting 0 by 0, which is indeterminate form. So I have to give some substitution or some simplification. I'll take the denominator term, that is y is equal to pi minus 2x. I'm taking the denominator without the square. So from this 2x is pi minus y. From this x is pi by 2 minus y by 2. So our new limit will become y tending to 0, because when I substitute the value of x pi by 2 here, the value of y will become 0. So now limit y tending to 0, numerator is q into 1 minus sine of pi by 2 minus y by 2, then whole divided by y square. This numerator is 1 minus cos y by 2. 1 minus cos y by 2 whole divided by y square. If I apply 1 minus cos theta formula, 1 minus cos theta is 2 sin square theta by 2. So 2 sin square y by 4 whole divided by y square. This for convenient, I will write sin square as sin y by 4 into sin y by 4 twice whole divided by y square as y into y. Now I put 4 and by 4 so that this whole thing becomes 1 because sin x by x is 1. In the same way, if I put by 4 for the other term also, I will get this as 1. The remaining will be 2q by 16, which is q by 8. So by comparing all the three terms, first we got half, then we got p, now we got q by 8. By equating these two, I am getting the value of p as 1 by 2. By equating this first and the last, I will get q is equal to 4. Question number 11. Show that the equation of the normal at any point t on the curve x is equal to 3 cos t minus cos cube t and y is equal to 3 sin t minus sin cube t is 4 into y cos cube t minus x sin cube t equal to 3 sin 4t. This is given the parametric form. So first from the x, I will find dx by dt. So it is going to be minus 3 sin t, then minus, it will become plus 3 cos square t into minus sin t. So that's why I made plus in the middle. Okay. Here I can take 3 sin t common. If I take minus 3 sin t common, this will become 1 minus cos square t. That is sin square t. So this is going to be minus 3 sin cube t. In the same way, if I find dy by dt, so dx by dt, we got it. From y, I have to find dy by dt, that is 3 cos t minus 3 sin square t into cos t. If I take 3 cos t common, 1 minus sin square t, it is going to be sin 1 minus sin square t is cos square t. So totally 3 cos cube t. This is our dy by dt. Now for normal, we have to find dy by dx first. So this is 3 cos cube t whole divided by minus 3 sin cube t. So we can cancel this. So this is our m. Now equation of normal formula is y minus y1 equal to minus 1 by m into x minus x1. So y minus y1, y1 is nothing but y which is given in the question. I will straight away copy it. So minus 3 sin t plus sin cube t, because I am taking the minus sign inside directly. This is equal to minus 1 by m. So here we got m. So negative reciprocal if I take, it is going to be sin cube t by cos cube t, then into x minus x1. So x1 is nothing but the x which is given in the question. So 3 cos t plus cos cube t. Now this cos cube t I have to multiply with this entire term. So it is going to be cos cube t into y minus 3 sin t into cos cube t plus sin cube t into cos cube t equal to this sin cube I have to multiply with all the term. So this is going to be x sin cube t minus 3 cos t into sin cube t plus sin cube t into cos cube t. So we can cancel sin cube t and cos cube t on both the sides. Then in the proof I have y term first. So I will keep this here, y into cos cube t. This x term I will carry to the other side as minus x into sin cube t. equal to this term I'll take to the other side with plus. So 3 sin t cos cube t minus 3 cos t into sin cube t. Now I can take 3 sin t cos t common here. After taking common, we are left with cos square t minus sin square t, which we know cos 2t. Okay, and this entire part is sin 2t by 2. So 3 sin 2t by 2 into cos 2t. Then finally y cos cube t minus x sin cube t equal to 3 by 2 sin 2t into cos 2t. This is once again sin 4t by 2. Everything is applied from the formula sin 2a equal to 2 sin a cos a. So when you have only sin a and cos a, this 2 will come down. Here instead of a we have 2t. So totally this is 3 by 2 into sin 4t by 2. So this 2 into 2 4 I'll take to the other side. So 4 into y cos cube t minus x sin cube t is going to be 3 sin 4t. So we got the proof. Question number 12, integration of 3 sin theta minus 2 into cos theta whole divided by 5 minus cos square theta minus 4 sin theta into d theta. So this denominator I want everything in terms of sin. So this cos square theta I will change into 1 minus sin square theta, but already minus cos square theta. So minus 1 plus sin square theta minus 4 sin theta into d theta. Okay. So now this will become 4. So I will rearrange the denominator 3 sin theta minus 2 into cos theta d theta whole divided by sin square theta minus 4 sin theta plus 4. We will take t is equal to sin theta. So dt is cos theta d theta. If I replace everything, 3t minus 2 into dt whole divided by t square minus 4t plus 4. This denominator again we can factorize as t minus 2 whole square. Now we can apply the partial fraction rule, which is a by the first factor plus b by square of it, because it is a repeated rule, repeated factors. So a by that factor plus b by square of it. Now if we take LCM, it is going to be a into t minus 2 plus b, okay, whole divided by t minus 2 whole square. Now I have to equate both the numerators. So here it is 3t minus 2 equal to a into t minus 2 plus b. If I take t is equal to 2, then this side 3 into 2 6 minus 2 4 equal to b, because a will become 0. The value of b we found. Now simply I'll take t as 0, then this side it will become minus 2 equal to minus 2a plus b. Since b is 4, I will put 4 here. Then if I carry this 4 to the other side, it will become minus 6 is equal to minus 2a. So a will become 3. After finding a and b value, straight away substitute in this expression and integrate. So a value is integral 3 dt by t minus 2 plus integral 4 by t minus 2 whole square dt. So this is 3 log mod of t minus 2. This is minus 4 by t minus 2 plus c, because this is 1 by x square integration is minus 1 by x. Now replace the value of t, which is sin theta minus 2, then minus 4 by sin theta minus 2 plus c. Question number 12, R part, we have to integrate 0 to pi e power 2x into sin pi by 4 plus x dx. We'll apply the isolate method here. So exponential we have. So in isolate we have trigonometric and exponential. So first comes u, that is trigonometric, sine of pi by 4 plus x, and dv is e power 2x dx. From u I have to find du, which is nothing but the differentiation is cos pi by 4 plus x. Then from the dv I have to integrate and find the v. So e power 2x by 2. Now integral uv u dv, the formula is uv minus integral v du. That is u dv. Integral u dv is uv minus integral v du. So if you substitute u, which is sin pi by 4 plus x, into v is e power 2x by 2, minus integral v is e power 2x by 2 into du, which is cos pi by 4 plus x dx. Now again we have to do isolate method for this. Now this is dv and this is u. So I will straight away apply. So I will name this as I equal to. So I equal to, the first term is as it is, sine of pi by 4 plus x into e power 2x by 2, minus open a bracket, uv is the formula. So u is what? Cos pi by 4 plus x. U v. I have to find v from this. That will become e power 2x by 4. That is, this is dv. If I find v, one more by 2 will come. Minus integral of this will come, and du. So what is the differentiation of cos? So minus sine. So I will put plus here. Sine of pi by 4 plus x dx. Now integration is finished. Now this question itself appeared again here except for this by 4. So I can substitute that as I by 4. So I equal to these terms as it is. I can take e power 2x by 2 common. Then inside the bracket I will be left with sine of pi by 4 plus x minus cos of pi by 4 plus x, but we have by 2 here because I took only 1 by 2 common. Then this minus sign is here, which is common. So here it will become minus I by 4. So I have to bring this I by 4 to the other side. Already here it is I. So I plus I by 4 is 5I by 4. So if I keep I alone here, 4 by 5 will come on the other side. So the rest of the terms I have to write as it is. Sine of pi by 4 plus x minus 1 by 2 cos of pi by 4 plus x. Now for the entire thing we have to substitute the limit which is given in the question, 0 to pi. When I substitute the upper limit, so the value of I equal to 4 by 5, we can keep it outside separately. So here it will become e power 2 pi here it will become sine pi by 4 plus pi. Okay, it will become minus sine pi by 4, this which is minus 1 by root 2, because it will be in the third quadrant. Then minus 1 by 2, if I substitute pi here, it will become minus cos pi by 4, but I can put plus cos pi by 4, which is 1 by root 2. Then minus lower limit. So for lower limit, if I put 0 here, it is going to be e power 0, which is 1. Then this will become sine pi by 4, which is 1 by root 2. Then this will become cos pi by 4. So minus 1 by 2 root 2. Okay. Now this is 4 by 5 e power 2 pi. We can take LCM. So you will put 2 and 2. So the common denominator is 2 root 2. In the numerator it will become minus 1. Okay. This is separate. Then in the same way, if I put 2 and 2 here, it will become minus 1 by 2 root 2. So I can take minus 1 by 2 root 2 common. So 4 by 5 into minus 1 by 2 root 2, if I take it common, I will be left with e power 2 pi plus 1. So if you want, we can cancel this also. So answer is minus, even this also we can cancel. So answer is minus root 2 by 5 into e power 2 pi plus 1. One more thing, we forgot to write a 2 here. When we took 2 common, we wrote in the previous step, but this 2 is missing from this step onwards. So denominator will have a extra 2. So after cancelling this, this will become root 2. So answer is minus 1 by 5 root 2 into e power 2 pi plus 1. Question number 13, integral root x by root of a cube minus x cube dx. Root x whole divided by this denominator, we are going to rearrange. This a power 3 can be written as a power 3 by 2 whole square. In the same way, x power 3 by 2 whole square, that will become x cube. Okay, because we are going to give substitution, t is equal to x power 3 by 2. So dt will become 3 by 2, x power 3 by 2 minus 1 is 1 by 2 dx. So 2 by 3 dt is root x dx. So I can replace the numerator as 2 by 3 dt whole divided by root of a power 3 by 2 whole square minus t square. This is sine inverse x by a formula. So 2 by 3 sine inverse t by a, which is a power 3 by 2. And we have to replace the t. T is nothing but x power 3 by 2. So 2 by 3 sine inverse x power 3 by 2 by a power 3 by 2 plus c. Question number 14, integral minus 1 to 2 mod x cube minus x dx. Equate the term inside the mod to 0 and take the common term and factorize. We left with x minus 1 into x plus 1 into x equal to 0. By equating individually to 0, I will get x as 0 minus 1 plus 1. Actually this is plus 1 and the last is the minus 1. Now take a number line. We have from minus 1 to 2 as the limit given in the question. In that we can mark 0 and 1 here, and this minus 1 is already a part of the given limit. Now we have 3 part. In this I have to find where it is positive and negative. This mod, entire mod is this term, isn't it? So if I take this interval from 1 to 2, if I take 1.5, this is positive, this is positive. So totally it is positive here. If I take any value from 0 to 1, this will be negative, but the other two are positive. So totally it is minus. Similarly, if I take a negative number, all the three are negative. So it is, sorry, if I take a value from minus 1 to 0, for example, minus 0.5, this will become positive. This is negative and this is negative. So totally it is positive. So this mod is split into three parts. That is, first part is minus 1 to 0 x cube minus x dx, then minus times of x cube minus x dx, that interval is from 0 to 1, then 1 to 2, again positive x cube minus x dx. Now integrate and substitute the limit. So this is x power 4 by 4 minus x square by 2, limit is from minus 1 to 0, minus of, again the same thing, but the limits are different. Third is also x power 4 by 4 minus x square by 2 from 1 to 2. Now if you put an upper limit, it is going to be 0. When I put a lower limit, it is going to become 1 by 4 minus 1 by 2. Then minus of, if I put the upper limit 1 by 4 minus 1 by 2, then lower limit is 0. So no need to write. Then if I put upper limit 2 power 4, 16, 16 by 4 is 4 minus 2 square 4, 4 by 2 it is 2. Then minus lower limit is 1 by 4 minus 1 by 2. I substituted all the limits. Now on simplification, the first term is minus of minus 1 by 4. Then this is also minus 1 by 4. Then the last term is 2 minus of minus 1 by 4 plus 1 by 4. So totally this is 1 by 4 plus 1 by 4. After taking LCM, 9 by 4. Totally 11 by 4. Question number 15. Find the particular solution of the differential equation. We have variable separable, homogeneous and PQ method, but this problem appears to be variable separable. Let's try to separate the variable. So for that, we'll keep 2xy dy on this side, and the remaining term I'll take to the other side, 1 minus y square into 1 plus log x dx. Now keep 2y dy here, whole divided by this term along with the minus sign. If I take it here, y square minus 1, and here it is 1 plus log x dx whole divided by this x. I have to bring it down. Now I separated the variables. I can go for integration. Now t equal to y square minus 1, if I take, dt will become 2y dy. In the same way, if I take u is equal to 1 plus log x, and du will become 1 by x dx. So if I substitute here, this is going to be dt by t equal to integral u du, because this whole thing is du and this whole thing is u. So u du. On integration, this will become log t equal to u square by 2 plus c. We will replace the value of t, which is y square minus 1, equal to u, which is 1 plus log x whole square by 2 plus c. The given condition we have to use to find the value of c, which is y is equal to 0 and x equal to 1. When y is 0, I will get log of minus 1 because it is inside the mod. So anyway it is log 1, which is 0, equal to 1. Log 1 is again 0 when I substitute x value here. So I am left with only 1 by 2 as the value plus c. So from this, the value of c is minus 1 by 2. So we'll substitute here. So log of y square minus 1 equal to 1 plus log x whole square by 2 minus 1 by 2. Since this is having a common denominator, I can carry to the other side 2 log of mod y square minus 1 equal to 1 plus log x whole square minus 1. If you want, we can take this minus also here. So 2 log of y square minus 1 plus 1 equal to 1 plus log x whole square. Question number 16. Find the general solution of the following differential equation. This question is using the PQ method. For that, I have to rearrange the equation as dy by dx plus py equal to q form. But this one is the dx by dy plus px equal to q, this form. Because we have only one x term left, so it has to be this form. For rearranging this, we will keep 1 plus y square here equal to minus of the other term. So I will take the minus inside. So e power tan inverse y minus x into dy by dx. I took the minus inside. Now this dy by dx I will carry to this side. So it is going to become dx by dy equal to e power tan inverse y minus x. So I can divide throughout by 1 plus y square, then only I will get this form. So the term is dx by dy equal to e power tan inverse y minus x. I will divide individually, so that in next step I am going to carry this term to the other side. Then I got the general form dx by dy plus x by 1 plus y square equal to e power tan inverse y by 1 plus y square. So here p equal to what is with y, sorry, what is with x, that is 1 by 1 plus y square, and q is the other side term, which is e power tan inverse y by 1 plus y square. Now we have to find integrating factor. The formula is e power integral p dy. So e power integral 1 by 1 plus y square dy, which is nothing but e power tan inverse y. Now coming to the solution, x into integrating factor equal to integral q into integrating factor into dy plus c. So x into e power tan inverse y equal to integral e power tan inverse y by 1 plus y square into e power tan inverse y dy. For integrating this, we have to go for substitution. T is equal to e power tan inverse y. So dt will become t e power tan inverse y will come again, then by 1 plus y square using the chain rule. So this is going to be t, and this entire term is dt. So if I substitute here, this is going to be integral t dt. So on integration we get t square by 2 plus c. Then we will replace the t. So from the other side, x into e power tan inverse y equal to e power 2 tan inverse y by 2 plus c. Question number 17. Show that the vectors a, b and c are coplanar if a plus b, b plus c and c plus a are coplanar. In the question it is given a plus b, b plus c and c plus a are coplanar. If three vectors are coplanar, the box product is 0. So in the question it is given box product of a plus b, b plus c comma c plus a equal to 0. When we have a box product, first element you write as it is, then dot of second element cross third element. Okay. Now this cross product we will continue first. So outside a plus b is as it is. We have b cross c. I am multiplying each and every vector plus b cross a plus c cross c plus c cross a. Now c cross c is 0. So ignore this. To the remaining term, you multiply a separately and b separately. So this is a vector dot b cross c plus a vector dot b cross a plus a vector dot c cross a plus b vector dot b cross c plus b vector dot b cross a plus b vector dot c cross a. Now again we can use a box product, that is a comma b comma c scalar triple product when it is connected with one dot and cross. Here it is a comma b comma a. Then third is a comma c comma a. Then b comma b comma c. Then b comma b comma a. Then b comma c comma a. Sorry, this is comma. Then when box product having two identical element, that will become 0. So all these four terms become 0. Then finally we have only two terms remaining. So when BCA is there, we can write it as ABC. So 2 a comma b comma c we got as the answer. On the other side it is equal to 0. We have to keep writing it. So finally we got like this. It means by dividing by 2 we get a comma b comma c is also 0. This indicates that vector a, b and c are also coplanar. So a plus b comma b plus c comma c plus a vector is given as a coplanar. Using that we got a result a comma b comma c is also coplanar. Question number 18. Find the vector and Cartesian equation of the line through the given point 1 comma 2 comma minus 4 and perpendicular to the two lines. So we'll draw a small diagram. What is given in the question is we have to find the equation of a line. Okay, I'll take this line as AB and they have given that it is passing through 1 comma 2 comma minus 4. So I'll take this point A as 1 comma 2 comma minus 4. Then it is perpendicular to the two lines. So I'll draw one perpendicular line, another perpendicular line here, and I'll write only the DRs. This is a perpendicular line 1 and line 2. This DR is 3 comma minus 16 comma 7. So from the line, the first is the point, second is the DR. So I am taking the DR. Similarly for the second line, it is 3, 8 and minus 5. So I took the DR. Okay. Now, since we want the equation of the line, we'll write the equation of the line formula x minus x1 by a equal to y minus y1 by b is equal to z minus z1 by c. Substitute the point a for x1, y1, z1. So x minus 1 by a equal to y minus 2 by b equal to z plus 4 by c. Now the line AB equation we have, so its dr is a comma b comma c. So I'll write it here. Dr of the line AB is nothing but a comma b comma c. Then dr of the perpendicular line L1, which we wrote from the equation 3 minus 16 and 7. Then dr of perpendicular line 2, is 3, 8 and minus 5. Now from the diagram it is very clear that AB is perpendicular to the line 1 and AB is perpendicular to the line 2. So now I am going to use the perpendicular condition. So using perpendicular condition, A1 A2 plus B1 B2 plus C1 C2 equal to 0. So for using AB and L1, it is 3A minus 16B plus 7C is equal to 0. For using the perpendicular condition for AB and L2, 3A plus 8B minus 5C equal to 0. Now using cross multiplication method, we are going to find the value of A, B and C. So write A by, now write all the coefficient of B and C as a 2 by 2 determinant. So minus 16, 8, 7 minus 5 equal to B by. Now leave B, write only A and C. First I have to write the C coefficient, then A coefficient equal to C by, now leave C, write only A and B coefficient. So this is like a 2 by 2 determinant. If you find the value of this, then that is the ABC value itself. So A by, this is 80 minus 56, so 24, and B by, this is 21, 21 minus 15. So this is 21, actually there is a minus sign here, so it is minus 5. So 21 plus 15, so 36, and C by 24 plus 48, so 72. This we can reduce it as by 12 tables, so 2, 3 and 6. So this is the value of A, B and C that I can substitute here. So our answer is x minus 1 by 2 equal to y minus 2 by 3 equal to z plus 4 by 6. This is the Cartesian equation. Now when you want vector equation, it is nothing but r vector is equal to I plus 2j minus 4k plus lambda times of 2y plus 3j plus 6k. Question number 19. Three persons A, B and C apply for a job of manager in a private company. Chances of their selection A, B, C are given in the ratio. So from this we will write the value of probability of A getting selected is 1 out of 7. Because the total is 1:2:4. So the total ratio is 7. So 1 out of 7. And P of B is 2 out of 7. And P of C is 4 out of 7. Now the probability that A, B and C can introduce change to improve the profit, okay, of the company are 0.8, 0.5 and 0.3. That is probability for A introducing a change. I'll take E as introducing a change. So A introducing a change is E by A, which is nothing but 0.8. And P of E by B, that is B introducing a change is 0.5. And P of E by C, that is C introducing a change is 0.3. Now, if the change does not takes place, it means change did not takes place. So I have to write E dash. Find the probability that it is due to the appointment of C. So I have to find C of, that is P of C by E dash. Now write the formula, that is P of C into P of E dash by C whole divided by P of A into P of E dash by A plus P of B into P of E dash by B plus P of C into P of E dash by C. Now P of C is 4 by 7 into P of E dash by A. E by A is given as 0.8, so this will be 0.2. Sorry, we have to substitute for E dash by C from here 0.7. So this is 0.7 whole divided by, now P of A is 1 by 7 into E dash by A is zero point 0.2 plus 2 by 7 into E dash by B is zero point 0.5 plus 4 by 7 into zero point 0.7. We can cancel all the denominators 7. Then this value is 4 into 7. 4 into 7 is 28. So 2.8 whole divided by, this is zero point 0.2 plus 1 plus 2.8. On simplification, we get 2.8 whole divided by, the denominator is 0.2, so 1.2 totally 4.0. After moving the decimal, 28 by 40. If we cancel with 4 table, 7 by 10. A and B throw a pair of die alternatively. A wins the game if he get a total of 7 and B wins the game if he get a total of 10. If A starts the game, then find the probability that B wins. Since they are throwing a pair of die, getting a total of 7, the options are 1, 6, 2, 5, 3, 4, 4, 3, 5, 2 and 6, 1. Similarly, the sum 10 will be 4, 6, 5, 5, then 6, 4. Now, P of A is nothing but A is winning if the total of sum 7 comes. So there are 6 options out of 36. So it is 1 by 6. And P of B will be 3 by 36, that is 1 by 12. So from this I can write what is P of A dash, which is 5 by 6, and P of B dash, which is 11 by 12. Now if A starts the game, we want to know what is the probability that B wins. So if A starts, P of B winning the game, we have a series. Since A starts first, A has to fail, then only chance will come to B and B will win. Or what can happen is, first A start and A fail, then B fail, then again A get a chance, he fail, then B will get a chance, he win. Like this the series goes. Then again I will write one more term, P of A dash, P of B dash, then P of A dash, P of B dash, then again P of A dash, then P of B. That is, B is winning when he get a third time chance. Here he is winning in the first chance, here he is winning in the second chance, here is the third chance he is winning. Like this the series continues. Now I am going to put the value of P of A dash, which is 5 by 6 into B dash, sorry, B is 1 by 12 plus again 5 by 6 into B dash 11 by 12 into 5 by 6 into 1 by 12. Now A dash we have 3 times, so 5 by 6 whole cube. Then B dash we have 2 times, so 11 by 12 whole square. Then P of B is 1 by 12. Like this the series continue. This is an infinite GP. Suppose if I take term 2 divided by term 1, what will happen is 5 by 6 into 11 by 12 into 5 by 6 into 1 by 12 whole divided by 5 by 6 into 1 by 12. So we can cancel these two. Be left with 55 by 72. I'll check for the third term divided by the second term. So third term is 5 by 6 whole cube into 11 by 12 whole square into 1 by 12. Second term is 5 by 6 whole square into 11 by 12 into 1 by 12. So 1 by 12 you can cancel. This 5 by 6 whole square I can cut with this whole cube. So remaining 1 will be remaining. Then this 11 by 12 also I can cancel one term. So the remaining is 1 5 by 6 is remaining and 1 11 by 12 is remaining, which is same as this. It means this is infinite GP. For that, formula is S is equal to A by 1 minus R, where A is the first term. Common ratio is this 55 by 72. Therefore, A is nothing but the first term 5 by 72 here, and common ratio R is 55 by 72. So S is equal to A by 1 minus R. So A divided by 1 minus R. By taking LCM, LCM is 72. So 72 minus 55. So 72, if I subtract 55, 17 is remaining. So 5 by 72 into 72 by 17, answer is 5 by 17. So if A starts first, the probability that B wins is 5 by 17. Question number 20. Let f is from n to n and the given function is defined as f of x is equal to 9x square plus 6x minus 5. Show that f is ranging from n to s, where s is the range of f, is invertible, and find the inverse of f, and hence find the f inverse of 43 and f inverse of 163. For finding the inverse, first let us prove it is 1 to 1. So if I take f of x1 equal to f of x2, this is going to be 9x1 square plus 6x1 minus 5 equal to 9x2 square plus 6x2 minus 5. So we can cancel this. 9x1 square minus 9x2 square plus 6x1 minus 6x2 equal to 0. So if I take 9 common, I can factorize this as x1 plus 2 into x1 minus 2 minus x2, x1 plus x2 into x1 minus x2, minus 6 if I take common, x1 minus, sorry, plus 6 if I take common, x1 minus x2 equal to 0. Then we can take x1 minus x2 itself common. Finally we get 9x1 plus 9x2 plus 6 equal to 0. Anyway, this part is not possible because x is a natural number. So if I take any natural number for x1 and x2 and the sum of that cannot be 0, therefore the only thing left out is x1 minus x2 equal to 0. From this, x1 equal to x2, it means it is 1 to 1. Okay, now I have to get y in terms of x. So name the given function as y. The given function is y equal to 9x square plus 6x minus 5. So from this we get 9x square plus 6x minus 5 minus y equal to 0. Now we are going to use a quadratic equation formula. A is 9, B is 6, C is minus 5 minus y. So x is equal to minus b plus or minus root of b square minus 4ac whole divided by 2a. On simplifying this, inside the root we have 36 and 36. If I take it out, it will come out as 6. This will become 1. And these two minus, if I put it here, it will become plus here. So plus 5 plus y whole divided by 18. Again I can take 6 common. So minus 1 plus or minus root of y plus 6 whole divided by 18. So finally this is minus 1 plus or minus root of y plus 6 by 3. And the function f is given from natural number to natural number in the starting. So y is a natural number, and if I take this plus or minus separately, we will be getting like this. Since x is also natural number, this is not possible because both are negative. Therefore, I will take this function g of y as minus 1 plus root y plus 6 by 3. So, for any value of y from the natural number, there exists a pre-image. So, I can say y belong to S, okay, which is the range of the S. There exists a pre-image x belong to n in domain. That is, it is not for all the value the pre-image exists, only when y belong to the S. S is nothing but the range of the function. So for that pre-image exists. Therefore it is on to. Since the function is 1 to 1 and on to, inverse exists, and the inverse is g of y. This is one procedure for proving the inverse exists, and finding the inverse. We can say it is 1 to 1 and on to, therefore inverse exists. I will also tell you the other procedure by doing a composite function f dot g and g dot f. So for that I have to do f dot g and g dot f. So I'll copy the function. We are going to do f dot g of y first. It means f of g of y. So I'll copy the g of y, which is inside the function f, minus 1 plus root y plus 6 by 3. Now this whole term is considered as x, and we have to substitute in the f of x. So that is going to be 9 into minus 1 plus root y plus 6 by 3 whole square plus 6 into minus 1 plus root y plus 6 by 3 minus 5. The first term is a minus b whole square form. So it is going to be 1 plus y plus 6 minus 2 root y plus 6 whole divided by 9. So we can cancel this. Here after cancelling the 6 and 3, if you multiply the 2 inside, it is going to be minus 2 plus 2 root y plus 6 minus 5. So these two we can cancel, and 1 plus 6 is 7, minus 2 minus 5 is also 7. So finally I am left with only y. Now in the same way I am going to do g of f of x, which is nothing but g, copy the f of x function, which is 9x square plus 6x minus 5. Now this whole thing is considered as y, and we have to substitute here. So minus 1 plus root of 9x square plus 6x. If I put minus 5, already plus 6 is there. So plus 1 I will get whole divided by 3. This entire term is 3x plus 1 whole square, which is inside the root. So I will write 3x plus 1 by 3. After cancelling this, we left with only x. Since f of g of y we got it as y, and g of f of x we got it as x, therefore f is invertible and inverse is g. Now additionally they want f inverse of 43. So F inverse is nothing but g of y, right? So we are going to substitute the value in the g of y. I'll do it here. They want F inverse of 43. Basically, it is g of 43. And what is g of y? Minus 1 plus root of y plus 6. So 43 plus 6 whole divided by 3. So the value is minus 1 plus this is 49. So I can directly write it as root of it 7. So 6 by 3, which is 2. Similarly, they want f inverse of 163, which is nothing but g of 163. So minus 1 plus root 163 plus 6 by 3, which is 169. So root of it will be 13. So minus 1 plus 13 by 3. So 12 by 3, which is 4. Question number 21. Prove that the given determinant is divisible by x plus y plus z and hence find the quotient. See, for the given determinant, I am going to do C1 gives C1 plus C2 plus C3. So the first column will become xy plus yz plus zx minus x square minus y square minus z square. Similarly, the second element also xy plus yz plus zx minus x square minus y square minus z square, and third element also same. Then the remaining element will write as it is zx minus y square, xy minus z square, yz minus x square. Then xy minus z square, yz minus x square, zx minus y square. Okay. Now taking xy plus yz plus zx minus x square minus y square minus z square from column 1. So column 1, if xy plus yz plus zx minus x square minus y square minus z square is common, the remaining will be 1 1 1. Here it is going to be zx minus y square, xy minus z square, yz minus x square, then xy minus z square, yz minus x square, zx minus y square. After this, we can do R2 gives R2 minus R1 and R3 gives R3 minus R1. So the outside element xy plus yz plus zx minus x square minus y square minus z square we will write as it is. Now R1 we are not doing anything, so we will write as it is. R2 is R2 minus R1, so this will become 0. Now when I subtract these two, it will become xy minus z square minus zx plus y square. In the same way, yz minus x square minus xy plus z square. Again here 0, then R3 minus R1. So this and this. So yz minus x square minus xz plus y square. Then zx minus y square minus xy plus z square. Okay. Now after this, we have to group these two and these two. Similarly for the other terms also. When I group and write, before that the outside term xy plus yz plus zx minus x square minus y square minus z square outside. Then first column as it is, Then second column, first element as it is. Here it is xy minus zx plus y square minus z square. Then yz minus zx plus y square minus x square. This will be xy minus z square, yz minus xy plus z square minus x square, then zx minus xy plus z square minus y square. Okay. Then again the outside term as it is. So I am going to factorize these terms. Before that, once again the outside term we will write as it is. Okay, this is 1 0 0 zx minus y square as it is. From here, if I take x common, it is going to be y minus z. Then this is y plus z into y minus z. Similarly, if I take z common here, it is going to be y minus x. Here it is y plus x into y minus x. Then coming to the third column, in the same way, if I factorize, y common z minus x plus z plus x into z minus x. Then here x common into z minus y plus z plus y into z minus y. Now again we can take y minus z common in this particular element. Like that, what is common we will take it out. So xy plus yz plus zx minus x square minus y square minus z square 1 0 0 zx minus y square. When I take y minus z common, the remaining will be x plus y plus z. Here y minus x common, so remaining will be x plus y plus z. Here xy minus z square, then z minus x common, so x plus y plus z. Then here z minus y common, we have x plus z plus y. So we can see x plus y plus z is common in the second row and third row. So we will take it as common outside. So taking x plus y plus z from R2 and R3. So xy plus yz plus zx minus x square minus y square minus z square we have. Along with that we have x plus y plus z whole square. Then 1 0 0 zx minus y square y minus z y minus x, then xy minus z square z minus x and z minus y. Now we can expand the determinant because already we got two zeros, so I will expand along with this. So before that, all the outside term xy plus yz plus zx minus x square minus y square minus z square into x plus y plus z whole square. Now this expansion will be 1 into y minus z into z minus y minus of y minus x into z minus x. Then we have to expand these terms. It will be yz minus y square minus z square plus zy. Then this is yz, so minus yz. Then this will be minus xy, so plus xy, because outside there is a minus sign, I am including that here itself. Then minus xz, so plus xz, then plus x square, so minus x square. Finally we can cancel these two. So once again I am getting similar term to this. So the final answer is x plus y plus z whole square into xy plus yz plus zx minus x square minus y square minus z square whole square we got. The question is we have to prove it is divisible by, this determinant is divisible by x plus y plus z. Since we got this term, we can say it is divisible by x plus y plus z, and hence find its quotient means after dividing this one term will go off. So the quotient will be the remaining one term, that is x plus y plus z, and this whole square term xy plus yz plus zx minus x square minus y square minus z square whole square. So this is the quotient. Question number 21, our choice. Using elementary transformation, find the inverse of the given matrix. So the matrix A is given as 8, 4, 3, 2, 1, 1, 1, 2, 2. And after finding this, we have to solve the system of given equation using this inverse. Okay. So first we will do the elementary transformation. For that I have to write A equal to IA. So we'll copy A, which is 8, 4, 3, 2, 1, 1, 1, 2, 2. That is equal to identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 into A. We have to make 1 here, but already there is a 1 here. So I will interchange the rows. So R1 interchange R3. So what will happen? 1, 2, 2 will come in the first row, then 2, 1, 1, then 8, 4, 3. Here also R3 will come in the first row, R2 as it is, then R1 will come here, then into A. Now using this one, make two zeros here. That can be done by doing R2 gives R2 minus 2R1 and R3 gives R3 minus 8R1. Okay, I'll continue here. Now R1 we are not doing anything. So I'll write the R1 as it is, which is 1, 2, 2. Okay. Now if I do R2 minus 2R1, this will become 0. Then 2 minus 4, that is minus 3. Then 1 minus 4, sorry, 1 minus 4, again 1 minus 4. So minus 3 minus 3. Okay. That is R2, this element minus of 2 times of this. So it will become 1 minus 4, so minus 3. Now coming to the third row, this minus 8 times of R1, so 0. This minus 8 times of this, so 4 minus 16, so minus 12. Then 3 minus 16, so minus 13, equal to, same thing I have to do here, 0, 0, 1 I will write as it is because we are not doing anything with the R1. Then this minus 2 times of this will be 0, this minus 2 times of this will be 1, this minus 2 times of this will be minus 2. Then this minus 8 times will be 1, this minus 8 times will be 0, and this minus 8 times will be minus 8 into A. Now after making this, I have to make 1 for this element. For this, I can divide the entire row 2 by minus 3. So again, first row as it is, this is 0, 1, 1, then this is 0, minus 12, minus 13, then 0, 0, 1, 0, minus 1 by 3 and 2 by 3. This is as it is 1 0 minus 8. The whole thing into A. Okay. Now using this one, I have to make two zeros above and below. For this, I have to do R1 gives R1 minus 2 times of R2 and R3 gives R3 plus 12 times of R2. So always make use of this 1. So first R1 I will write, which is R1 minus 2 times of this. It will become 1 only. 2 minus 2 times of this will become 0. Then 2 minus 2 times of this will become 0 again. Okay. Then R2 we are not doing anything, so I will copy as it is. Then R3 plus 12 times of this, it will become 12. This plus 12 times of this, so it is going to be 24. So totally 12 I will get. Then this plus 12 times of this, so 24 minus 13, so we get 11. Okay. The same way I have to do for the other side also. So R1 minus 2 times of this, so 0. This minus 2 times of this, so 2 by 3. This minus 2 times of this, so it is going to be 1 minus 4 by 3, which is minus 1 by 3. Then R2 we will copy as it is. Then R3 plus 12 times of this, that is here, plus 12 times of this. Just a minute. I think in the R1, sorry, here these two numbers by mistake we took it from as R1. Actually it is minus 12 plus 12 times of this, so it is going to be 0 here. Okay. Then this plus 12 times of this will become minus 1. So this is minus 1. So this is 0 and R3 plus 12 times of this. So that will become minus 1. Then coming to the other side, R3 plus 12 times of this will be 1. This plus 12 times of this will be minus 4 and minus 8 plus 12 times of 2 by 3. So this will be 4. So I am getting 0. Then after that we have to make this as 1. Okay. So for that I have to divide, and even this is 0. Okay. For that I have to divide entire R3 as R3 by minus 1. So first row as it is, second row as it is, third row this will become 1. Okay. Actually this is 1. Then 0 0 1. And on the other side 0 2 by 3 minus 1 by 3, and we have to write A here. Then 0 minus 1 by 3 2 by 3, then minus 1 4 0. Now we have to get 1 here, but already we got, and I have to make 0 here using this one. That can be done by doing R2 gives R2 minus R3. Okay. So I'll do it here. Now R1 we will write as it is, that is 1 0 0. R2 is R2 minus R3. So that is going to be 0, 1, 0. Then the last row as it is. Now again R1 we write as it is. Then R2 minus R3, this will become 1. Then minus 1 by 3 minus 4. So minus 1 minus 12 by 3. So minus 13 by 3. Then R2 minus R1, this will become 2 by 3. Then minus 1, 4, 0, we will keep as it is. Into A is there. Okay. So since we got identity here, our A inverse is 0, 2 by 3, minus 1 by 3, 1, minus 13 by 3, 2 by 3, then minus 1, 4 and 0. If you want, you can take 1 by 3 common. Finally, it will become 0, 2, minus 1. Then here 1 by 3 is not there. So 3 I have to put. This will become minus 13. This will become 2. Then minus 3, 12 and 0. We'll check once again. So now we got the A inverse. Using it, we have to solve the equation. The three equations are 8x plus 4y plus 3z is equal to 19. Then 2x plus y plus z is equal to 5. Then x plus 2y plus 2z is equal to 7. Now this equation should be written as a matrix product by taking all the coefficients like this. Okay, into xyz equal to 19, 5 and 7. This is of the form Ax equal to B. So from this x is equal to A inverse into B. Since we got A inverse here, I am going to make use of it. So 1 by 3 into 0, 2, minus 1, 3 minus 13, 2, minus 3, 12, 0. We have to multiply this with 19, 5 and 7. After that, we will get the value of x, which is nothing but xyz. So we'll do the multiplication here. Now let's multiply here. So x is nothing but 1 by 3. We have to multiply this entire row with this entire column. So the first element will be 0 plus 10 minus 7. Then the second will be 57 minus 65 plus 14. Then the third will be minus 57 plus 60 plus 0. So totally 1 by 3 into this is 3. This is going to be minus 8. So 14 minus 8 will be 6 and this will be 3. So we got answer as after dividing by 3 1, 2 and 1. Now we have to verify this value using any of the equation. I will substitute in the first equation. So 8 plus 3. So I am getting 19. Therefore the value of x is 1, then y is 2 and z is 1. Question number 22. Show that the altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius r is 4r by 3. Also find the maximum volume in terms of the volume of the sphere. So consider this diagram. We have a sphere and we have a cone inside of the sphere. This is the center of the sphere. So this is radius r, but in the question they have given small r. So I will take it as small r itself. Then this also small r, and if I drop this height, I will take this as x. So the total height of the cone is r plus x. and this entire thing is capital R. Okay. Using the Pythagoras relation, we have small r square is equal to capital R square plus x square. Now from the question they have given it's a maximum volume. So volume of the cone is 1 by 3 pi r square h. I am using capital R because we named it as a capital R for the cone. Here 1 by 3 pi capital R square from here is r square minus x square, then h is r plus x. So I got f of x in terms of r and x, where r is the constant. So further we can factorize this. So this is pi by 3. This is r plus x into r minus x. Already there is an r plus x. So r plus x whole square into r minus x. Now find f dash of x, which is nothing but 1 by 3 using UV method, r plus x into minus 1 plus r minus x into 2 into r plus x. Totally I can take r plus x common and we have pi by 3 outside. After taking common, actually this is square. So the remaining is minus r minus x because one term I took common. So remaining is there and there is a minus sign also. Then plus 2r minus 2x. Totally simplifying this, we get f of x is equal to pi by 3 into r plus x, and the remaining term is this and this will give r, and minus x minus 2x is minus 3x. We have to equate to 0 so that x is equal to minus r and x is equal to r by 3. Anyway, this is not possible because x is a length, it cannot be negative. Now find second order, again using UV method. So r plus x into minus 3 plus r minus 3x into 1. Wherever x is there, substitute x is equal to r by 3. So this will become 0. Here if this is r by 3, r plus r by 3 is 4r by 3 into minus 3, and there is also a pi by 3. Since this is negative, therefore it is maximum. Now we have to prove height is equal to 4r. According to the diagram, height is equal to 4r by 3. According to the diagram, h is equal to r plus x. So for x we have to substitute r by 3. We found x as r by 3 here. So on simplification we get 4r by 3. Now we have to find the maximum volume in terms of the sphere. So for maximum volume I have to substitute in the volume. This is the volume pi by 3 into r plus r by 3 whole square into r minus r by 3. So totally this is pi by 3. This whole thing is 4r by 3 after taking LCM. So by squaring it, I will get 16r square by 9 into 2r by 3. Then I will take 8 by 27 common. After taking 8 from this, totally this is 32. So 4 will be remaining. If I take this common, remaining 3 will be remaining the denominator. So pi, and this is r also here. So r cube. So I am getting 8 by 27 times the volume of the sphere. So volume of cone, what we got is 8 by 27 times volume of sphere. Question number 22, R choice. Find the interval in which it is strictly increasing or decreasing. F of x is given as 3 sin 3x minus cos 3x. So sin 3x minus cos 3x. Find f dash of x. This will become 3 cos 3x plus 3 sin 3x equal to 0. After taking 3 common, since other side is 0, that will go off. So cos 3x plus sin 3x equal to 0 we will get. So if I carry this term to the other side, I will get sine 3x equal to minus cos 3x. From this, tan 3x is equal to minus 1. It means the value of 3x should be 3 pi by 4 and 7 pi by 4 because it is in the second and fourth quadrant. Then each value of x will be pi by 4 and 7 pi by 12. Okay. Now put a number line. They have given the interval from 0 to pi only. Okay. So the value pi by 4 will come here and 7 pi by 4 also will, say pi by 12 also will come here. So these are the intervals. Since the given interval is till pi, we have to check whether any other value also present beyond 7 pi by 12. So I'll add one more value. So 3 pi by 4 plus pi I am getting 7 pi by 4. Again plus pi if I put I will get 11 pi by 4. Okay. But x will be 11 pi by 12. So this also I should include in the interval. So I will extend the line. Here let it be pi. So 11 pi by 12. So we have 4 parts, 0 to pi by 4 to 7 pi by 12, 7 pi by 12 to 11 pi by 12, then 11 pi by 2 till pi. So we'll make a box where we have intervals 0 comma pi by 4, then pi by 4 comma 7 pi by 12, then 7 pi by 12 comma 11 pi by 12, then 11 pi by 12 comma pi. Then we have to take the f dash of x which we equated to 0, this one. So f dash of x equal to, if you want you can keep the 3 outside also, anyway it doesn't matter because it is positive. So cos 3x plus sin 3x we have. Okay. Now take one value from this interval, for example pi by 6. So if I take f dash of pi by 6, what will happen? So 3 into pi by 6 will become pi by 2. So cos pi by 2 and sin pi by 2. Basically the answer is 3. So which is greater than 0. So here the nature of the function where it is strictly increasing. Coming to the next interval, I can take the value f dash of pi by 3. Okay, if I take pi by 3, first I have to check whether it is between 7 pi by 12. So if I take pi by 3, I will make common denominator. I'm getting 4 pi by 12 which will be less than 7 pi by 12. Yeah. So if I take pi by 3, here if I substitute cos pi by 3 is minus 3 into pi by 3 is cos pi then sin pi. So I'm getting minus 3 which is less than 0, so it is decreasing. Then coming to this, I can go for 8 pi by 12 in this interval. So 8 pi by 12 is nothing but 2 pi by 3. So if I put 2 pi by 3 here, I will get cos 2 pi then sin 2 pi. So cos 2 pi is 1, sin 2 pi is 0. So answer is 3 again. So I'm getting greater than 0. So it is increasing, strictly increasing. Then for this interval, which is a very small interval, if I take any value from this, since it is coming alternate, I have to get less than 0. So it will be decreasing. But what value I can take is, see this is 11 pi by 12 and this is pi. I can take it as 12 pi by 12. So in between we have very small region. So I will go for 11.5 pi by 12. Okay. Then substituting this value, seeing the quadrant, putting the sign, we will be getting negative. So I can say it is strictly decreasing. So the interval in which it is increasing are the second interval, sorry, increasing are first interval and third interval, decreasing are second interval and fourth interval. Question number 23. Using integration, find the area of the given region. The two curves given are, one is x square plus y square less than or equal to 2ax and other one is y square is equal to greater than or equal to ax then x comma y greater than or equal to 0. This 2ax will take to the other side. So x square minus 2ax plus y square less than or equal to 0. We have to do completing square. So this is x minus a whole square plus y square minus a square equal to 0. So we get x minus a whole square plus y square is equal to a square. So this is a circle with center a comma 0 and the radius is also a. Now this is a parabola open right side. First I have to find the meeting point of both. So I will substitute the y square here. So what will happen? X square plus ax less than or equal to 2ax. By taking this to the other side, it will become ax. So x square equal to ax. After cancelling this, I will get x is equal to a. Another meeting point will be origin because I cancel the x. Now we will plot both the curves. That is, one is a circle with center a comma 0. So I will center a comma 0. We have a circle like this. So this is a comma 0 and the parabola is right side open, but this meeting point is also a. So I have to draw correctly like this. So parabola will come like this. But in the question they have given that x and y greater than or equal to 0. So the region which we have to find is this plus this. And I have to check whether this is the correct region. For that you take a comma 0 is a point which is lying inside the circle and inside the parabola. If I substitute in the circle, so x square which is a square plus 0 less than or equal to 2a square. So it is true. Similarly in the parabola y square is greater than or equal to ax. So if I substitute a comma 0, what happens? It will become 0 greater than or equal to a square. So which is not true. So basically the region which we have to find is this region. Okay. For that I have to take top curve minus bottom curve. So I will write the expression here. Area equal to integral 0 to a. Top curve is what? Circle. I can take from here, which is root of a square minus x minus a whole square minus bottom curve. That is, I have to take what is y from this, which is root a root x dx. Integrating this using the formula, this is going to be x minus a by 2, copy the question, plus a square by 2 sin inverse x by a minus root a into x power 3 by 2 into 2 by 3. And it's easy limit to substitute because the first part is 0 when I substitute a, because this entire term will become 0. Then this will become 0 again. I will be left with only this term, that is root a into 2 by 3 then into a power 3 by 2 with minus sign. Upper limit minus lower limit when I substitute, this part will become 0 because when I put 0 here, this will go off. So a square minus a square is 0. Only this will be remaining, that is a square by 2 sin inverse, when this is 0, sin inverse minus 1, and the other part is also 0. So totally this power half and 3 by 2 if I add, it will become 2. So minus 2 by 3 a square, this will become plus now. So plus pi by 2 a square by 2, because sin inverse 1 is pi by 2. So totally the answer is pi a square by 4 minus 2 by 3 a square units. Question number 24. Find the coordinate of the point where the line through the given point A and B crosses the plane through the 3 points. So let us take a diagram. This is the plane. It is passing through 3 points L, M, N. Okay, and the line crosses the plane, so it is cutting like this and passing through like this. I'll take the meeting point as P, and the line is having 2 points A and B, which is given in the question. Now I have to find the point P. Then also find the ratio in which P divide the line segment AB. So for convenient, I will take the B point instead of here, I will take it here. Okay. Now I have to find the equation of the line first. So equation of the line formula is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1 is the formula. Now what is point A, which is 3 minus 4 minus 5, and point B is 2 minus 3 and 1. So x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2, which is 1, z minus z2 minus z1. So this is x minus 3 by minus 1 equal to y plus 4 by 1 equal to z plus 5 by 6. Okay, I got the equation of the line. Now we'll keep the equation of the line alone separately. Now coming to the equation of the plane. Equation of the plane, we have a determinant formula x minus x1, x2 minus x1, x3 minus x1. In the same way, y minus y1, y2 minus y1, y3 minus y1, z minus z1, z2 minus z1, z3 minus z1 equal to 0. Now point L is given as 2 comma 2 comma 1. M is 301. N is 4 minus 1 0. So using the determinant x minus x1, x2 minus x1, x3 minus x1, y minus y1, y2 minus y1, y3 minus y1. Then z minus z1, z2 minus z1, z3 minus z1 equal to 0. This one x minus 2, y minus 2, z minus 1 as it is. This is 1 minus 2 0, then 2 minus 3 minus 1. Okay, we'll expand this determinant. So this is going to be x minus 2 into 2 minus y minus 2 into minus 1, then plus z minus 1 into minus 3 plus 4, so 1, totally equal to 0. So the equation of the plane is 2x minus 4 plus y plus 2 plus z minus 1 is equal to 0. So totally we get 2x plus y plus z and minus 3 equal to 0. And this term is minus 2 only. Okay, so this number is not minus 3. That is, when I multiply this will become plus. So y minus 2 is remaining. Then minus 4 minus 2 minus 1 is minus 7. So this is the equation of the plane we got. So we got the equation of the plane and the equation of the line separately. Now we have to find the meeting point. Now for finding the meeting point, let us take this point P as x1, y1, z1. This point P is a point on the line as well as point on the plane. So if I substitute this point P in the line equation, we will be getting x1 minus 3 by minus 1 equal to y1 plus 4 by 1 equal to z1 plus 5 by 6 equal to k. Now equating separately, x1 will be minus k plus 3, y1 will be k minus 4, z1 will be 6k minus 5. Now these points x1, y1, z1 lying on the plane. So I'm going to substitute this in the plane equation. So 2 into minus k plus 3 plus k minus 4 plus 6k minus 5, that is z, then minus 7 is equal to 0. So minus 2k plus 6 plus k minus 4 plus 6k minus 5 minus 7 equal to 0. So all the k terms if I add, it will be totally 5k. Then these numbers if I add, this is totally 2, then minus 10. So basically k value is 2. If I substitute k value 2 in this set of points, that will be the meeting point of the line and the plane. So x1 is going to be 1, y1 is going to be minus 2, and z1 is going to be 7. So 1 comma minus 2 comma 7. Now we have to find the ratio in which the point P divides the line segment AB. After finding this meeting point, we have to find the ratio in which P divides the line segment AB. So I will draw the line again, AB, and the point P is here, which we got it as 1 comma minus 2 comma 7. Point A is 3 minus 4 minus 5, and this is 2 comma minus 3 comma 1. We have to find this ratio, m is to n. Using the section formula, 2 into m plus 3 into n divided by m plus n. This is the x coordinate. But if I take the x coordinate and equate to this x coordinate, it is enough to get the ratio. So 2m plus 3n equal to m plus n. So m equal to minus 2n. So m by n is minus 2 by 1. Since the ratio is coming in the negative, the ratio is 2 is to 1, but externally it is dividing. So the point P divide the line segment AB in the ratio 2 is to 1 externally. Question number 25. An urn contains 3 white and 6 red. So 3 white and 6 red. 4 balls are drawn. So 4 balls drawn. That is with replacement. And we have to find the probability distribution of the number of red balls. So the random variables will be 0, 1, 2, 3, 4. Since 4 balls are drawn, corresponding P of x we have to find. Then we have to find the mean and the variance. Since it is with replacement, we have to write separately P of W, that is white ball. Probability of getting white is 3 out of 6, sorry, 3 out of 9, which is 1 by 3. And probability of red is 6 out of 9, which is 2 by 3. Now coming for the calculation, when P of x is equal to 0, all the 4 are not red. It means all the 4 are white. So P of W into P of W into P of W 4 times I have to put. By putting the value of 1 by 3 everywhere, I will be getting 1 by 3 whole power 4, which is 1 by 81. So this is 1 by 81. Now P of x is equal to 1 means it is 1 red and all the 3 are white. So P of W into P of W into P of W 3 times. This is 2 by 3 and the rest of the things are 1 by 3. But this red can be in any of the places, isn't it? Now here it is present in the first place. It can be in the second or third or fourth. So for including all the option, I have to put into 4C1, which is 4. So totally it is 8 by 81. So for the second one, it is 8 by 81. Then P of x is equal to 2 is nothing but 2 red and 2 white. But once again, this red can be in the any of the two places. So out of the 4, it can be in any of the two places. So 4C2. So this is 2 by 3 into 2 by 3. Then 1 by 3 into 1 by 3. 4C2 is 4 into 3 by 1 into 2. Totally it is 6. Don't cancel anything with the denominator because we maintain the same denominator here. Denominator is always 81 and the numerator it is going to be 24. Now P of x is equal to 3 we have to find out. For P of x is equal to 3 red. So P of R into P of R into P of R and 1 white into 4C3. Red is what? 2 by 3. The rest of the things are, sorry, red is 2 by 3, 2 by 3, 3 times. Then 1 by 3. 4C3 is also 4C1, so it is 4. So the total value is 8432 by 81. So this is 32 by 81. And the last one, x is equal to 4 is nothing but all the 4 are red. So whole power 4. So red is what? 2 by 3 whole power 4, which will be 16 by 81. So we got the table. We have to check whether it is correct or not. We have to add all the probability value. It has to come to 1. So in the numerator we have 1 plus 8 plus 24 plus 32 plus 16. So we will add everything. These two will become 40. These two will become 40. 40 plus 40, 80. 80 plus 1, 81. So 81 by 81, which is 1. So it means the distribution table what we got is right. Now we have to find the mean and the variance. Now for finding mean, the formula is E of x sigma xi pi. So we have to multiply the probability and the x value. The first term if we multiply it is 0. Second term is 8 by 81 plus 48 by 81 plus 96 by 81 plus 64 by 81. So we'll add everything. The first term is, that is 8 and 48 is 56, then 96, then 64. So I'm going to add everything. So I'm getting 216. Now 216 divided by 81. Okay. We can cancel with 3 table or 9 itself directly. So if we cancel with 9, 9, 9, 81. 9 2 times 18, 36. So 9 4, 36. Again with 3 table if I cancel, 8 by 3. So mean is 8 by 3. Then for finding variance, we need E of x square. Then only we can find variance. E of x square is square the x, sigma xi square and pi. So if I square x and add, first term anyway 0, second term is 8 by 81 only. Then this is 4 into 24 by 81 plus 9 into 32 by 81 plus 16 into 16 by 81. Okay, we'll do the calculation here. So the first value is 8 plus 96 plus 32 into 9, 9 to 18, 27, 28. So 288 plus 256 whole divided by 81. So 288 plus 256 if I add, I'll get 544 plus 96 if I add 640, then I am getting 648 by 81. Now variance formula is E of x square minus E of x whole square. E of x square is 648 by 81 minus mean we got as 8 by 3. So if I square it, I'll get 64 by 9. So for making common denominator, I'll put into 9 here. So what is 64 into 9? 9 4 36, 9 6 54 57, 576 I am getting. So from 648 I have to subtract 576. So 2 7, that's all, 72. So 72 by 81. If I cancel with 9 table, I'll get 8 by 9. So the variance is 8 by 9. Mean is 8 by 3 and variance is 8 by 9. Question number 26. A manufacturer produces two products A and B. Both the products are processed on the two different machines. So the available capacity for the first machine is 12 hours and that of the second machine is 9 hours per day. Okay. So we have two products. I'll take the product as A and B here. That is X and Y. And the machine availability here. And I will take the machine 1, machine 2 here. The machine, the available capacity of the first machine is 12 hours. So it means it is available less than 12 hours. And the second is less than or equal to 9 hours. Each unit of the product A requires 3 hours on both the machine. So this is 3 and 3. And each unit of the product B requires 2 hours on the first and 1 hour on the second machine. Each unit of the product A is sold at rupees 7 profit and B for rupees 4 profit. So Z is equal to 7x plus 4y. Okay. Find the production level per day for maximum profit graphically. And here X and Y is obviously greater than or equal to 0. Now our equations are 3x plus 2y less than or equal to 12. So we'll make one LPP box here where we will take X and Y, X0, if X is 0, Y is 6, then if Y is 0, X is 4. Then the second equation is 3x plus Y less than or equal to 9. X and Y, these two are 0. When X is 0, Y is 9. When Y is 0, X is 3. So these are the points we have to plot in the graph. After plotting it, we have to calculate the Z value. That is, Z is nothing but 7x plus 4y. Now we'll plot the points here. I'll take the x-axis and y-axis. Since my graph is small, I'll go for 2 units. So in scale, I have to write x-axis and y-axis. 1 centimeter is equal to 2 units. So this is 0, 2, 4, 6, 8, 9, sorry, 10. Then 2, 4, 6, 8, 10. This is x and y. Okay. Now the first point is 0, 6. 0, 6 will be somewhere here and 4, 0 will be somewhere here. So we'll join this one. This is the first one. Then the other point is 0, 9, which will be somewhere here, and 3, 0, which will be somewhat here. Okay. Now we will join the lines. That is the first line, then the second one, okay. It is just a rough graph. So after plotting this, we have to shade the region. Since it is less than, it will be shaded towards the origin. Okay. Mark all the corner points A, B, C and D. Now the points are, point A is what? 0, 0. Point B is what? Point B is 3, 0. Point C is 2, 3. And point D is 0, 6. Find Z value for all the points. So here Z is 0. Here it is 21. Here it is 14 plus 12. So we get 26 and the other one is 24. They're asking for the maximum profit. So maximum profit is 26 at 2, 3.